Welcome to our channel. Subscribe and hit the bell so you won't miss our upcoming videos. Every time we look at an astronomical image, like the stunning ones produced by the James Webb Space Telescope or Hubble, it's natural to ask, are the colors I see real? If my eyes were powerful enough, or if I were near that object, would I really see those colors? In short, are we looking at a real photograph or an artificial creation? To answer this question, we need to explore both the process of creating astronomical images and the very concept of real colors. A photograph, a window into reality, or an interpretation of it. Before diving into astronomical images, it's important to understand that every photograph is a representation of reality, but never an exact copy. If you took two pictures of the same subject with two different cameras, you might get very different results. This happens because the final image depends on several factors: the type of lens, sensor, exposure time, and lighting conditions. In the past, with film photography, the type of chemical emulsion influenced the color and definition of the image. Today, in digital photography, the process is dominated by electronic sensors and processing algorithms that translate raw data captured by the camera into a visible image. Even the post-production stages, where the photographer can manipulate the image to enhance contrast or emphasize certain tones, add another layer of interpretation. As faithful as they may seem, photographs are always a translation of reality, not an exact reproduction. The goal is to create an image as faithful as possible, but technical and artistic limitations always play a role. Astronomical images, beyond our perception. Astronomical images follow the same principle, but with an added challenge. The objects we observe in the cosmos are often too distant or too faint to be seen directly with our eyes. Many of these celestial bodies emit radiation that doesn't even belong to visible light. So, asking what we would see with our own eyes doesn't make much sense, because we wouldn't be able to see them at all. Furthermore, astronomical images are not produced with the intention of merely creating a beautiful picture. Astronomers want to gather scientific data that can help them understand the universe. The images need to be rich in physical information, not just visually appealing. So, when we ask if the images we see are real photographs, the answer is yes, they are. However, not in the sense that they could be taken with a traditional camera. They are scientific images, created to faithfully represent phenomena that our eyes cannot directly perceive. The electromagnetic spectrum, light we cannot see. Another key point to understand the issue of colors is that our eyes are sensitive to only a small part of the electromagnetic spectrum, the so-called visible light. This includes colors ranging from red to violet, like those we see in a rainbow. Each of these colors corresponds to a specific wavelength of electromagnetic radiation. However, visible light is only a small fraction of the electromagnetic spectrum. There are many other forms of radiation we cannot see, such as infrared, ultraviolet, radio waves, X-rays, and gamma rays. These types of radiation can be emitted by astronomical objects and contain crucial information that our eyes could never detect. How we perceive colors. Our eyes see colors thanks to the presence of three types of receptors sensitive to red, green, and blue light. When light hits these receptors, the brain mixes the information to create the entire color spectrum. This is exactly the same principle used in electronic devices like computer screens, televisions, and smartphones. The pixels of these devices combine varying intensities of red, green, and blue to create all the colors we see. Similarly, in the past, color photography was developed using red, green, and blue filters to separate light into three monochrome images, which were then combined to reproduce a full range of colors. False colors in astronomical images. In astronomy, this process can be applied similarly. Telescopes can be equipped with filters that capture red, green, and blue light, allowing astronomers to combine these images to produce an approximation of what we would see with our eyes. However, this rarely happens. Most of the astronomical images we see are in false color, a term that means the colors represented do not necessarily match what we would see if we were close to the object. For example, in the famous images of nebulae taken by Hubble, the colors often represent chemical information rather than aesthetics. Blue might indicate the presence of oxygen, green hydrogen, and red nitrogen. If we could observe these objects with the naked eye, oxygen would appear greenish, and hydrogen and nitrogen would tend toward red. However, for scientific purposes, it is more useful to assign artificial colors that highlight differences in chemical composition. Multispectrum images and beyond visible light. Many of the most fascinating astronomical images combine data collected at different wavelengths, even beyond visible light. The James Webb Space Telescope, for example, observes primarily in the infrared, a wavelength invisible to our eyes, but crucial for seeing through cosmic dust and studying distant stars and galaxies. If we looked at these images with our eyes, we wouldn't see anything. However, the images reveal incredible details about the workings of the universe. In addition, other telescopes observe the universe in bands of the electromagnetic spectrum even farther from visible light, such as radio waves or X-rays. These instruments are essential for studying phenomena like black holes, neutron stars, or distant galaxies. The images we see in these bands have no direct correspondence to real colors, because this radiation cannot be seen by the human eye. In these cases, scientists assign arbitrary colors to highlight scientific information. An iconic example is the image of the black hole at the center of our galaxy, captured by the Event Horizon Telescope, which used radio wavelengths. Even the images of the cosmic microwave background, produced by microwave telescopes, are representations of radiation our eyes cannot see, but tell us the story of the universe shortly after the Big Bang. Ultimately, the astronomical images we see are faithful representations of reality, but through the use of sophisticated instruments that allow us to see beyond the limits of our senses. They are not real photographs in the common sense of the term, but they show us what truly exists in the universe in ways that would be impossible to perceive with the naked eye. Their purpose is not only aesthetic, but to reveal the hidden structure of the cosmos and the physical laws that govern it. And for this reason, every image tells us something deeper about the universe and our place in it.